Hello. On this video, we're going to continue on Chapter 1, Sections 1 and 2. We basically finished everything we needed to cover in Section 1 in the previous videos. We finished talking about one-to-one functions. So in this video, I'm going to focus more on Section 1.2. Okay, so we're going to be talking about finding the domain of algebraic functions. So first, let me tell you what an algebraic function is. We've actually used them in class before already, but I don't know if I actually called them algebraic functions. So what is an algebraic function? If your function is given by f of x equals some expression involving x, then that is what we call an algebraic function. Okay. So for example, I'll do this example later, but just so you can see, this function here, f of x equals square root of x, that's an algebraic function. Why? Because we have f of x equals some expression involving x. In this case, that expression is the square root of x. Now, we've seen other examples. For example, in previous videos, we saw the function f of x equals x plus 1. Again, this is an algebraic expression or an algebraic function because we have f of x equals some expression involving x, which in this case is x plus 1. And then notation-wise, just so you remember that f of x means outputs and the inputs are x. So this is telling you that, for example, the function f of x equals x plus 1 is telling you that given an input x, its corresponding output is x plus 1. Okay. So we saw this a couple of videos ago. Okay. So let me say a couple of things first, and this is the first bullet in this slide. So unless I stated otherwise, right, so unless I tell you explicitly differently, always assume that the functions we're working with have as input set the set of real numbers and as output set the set of real numbers. Okay? So using the notation we've been using in previous videos, you would write that like this. F maps the set of the real numbers into the set of real numbers. Now, this is going to be important for the method that we're going to show in this lecture for how to find the domain of a function, because as you know, or we've seen in previous videos, the domain of a function is a subset of its input set. And that's going to be important in how we approach finding the domain of functions. Okay? And since from now on, you're always going to assume that the function, given a function, its input set is the reals and its output set is the reals. I'll stop writing this out when I write functions. So if you notice in the previous videos, anytime I defined the function, I stated or I wrote something like this, right? So it was clear what the input set and the output sets were. Since now it's clear that it's always going to be the reals, unless I tell you otherwise. Like I might tell you, use the integers as the input set for this function, something like that. If I don't tell you that, then again, always assume that you're working with the real numbers, both as the input and the output. So having said that, what is the process that we're going to do to find the domain of a function? Okay. Well, in previous videos, we said the domain of a function defined as a set, or given the definition that we saw, is basically all of the elements or the subset of elements of the input set that are mapped to something under the function. Right? And we saw examples of cases where you're given a function and you're given an input set, and the domain of the function is not necessarily equal to the input set. It's always going to be a subset, right? So it's either equal or it's smaller. Okay. So the way we're going to do that more algorithmically is like this. So I'm going to start reading this bullet that's given by an orange star. So to find the domain of a function, all we're going to do is this. You're going to start with a set of real numbers. And then afterwards, what you're going to do is you're going to remove any inputs that you cannot plug into the expression that you're given for your function. Okay. And that's it. So start with the reals, remove any inputs that you cannot plug into the function. Whatever is left over, that is the domain of the function. Okay. So it's the same thing as finding the inputs that are mapped to something under the function. It's just a more algorithmic way of thinking about it. Okay. So let's do an example. We already covered this function in a couple of videos ago, but let's cover it again, but now using this process that we have here. So we want to find the domain of the function f of x equals the square root of x. And again, notice that I wrote it in parentheses, but I didn't actually write it in the statement of the problem. Right. So again, I'll stop writing this because it's assumed that this is the case. Okay. So in this case, since I didn't tell you that, I didn't tell you anything about the inputs and output sets, you know that they're the set of real numbers for both cases. Okay. So following the method that I wrote here, we're going to start with the set of real numbers. So let me draw it in purple. So start with the set of real numbers, and then we're going to remove any input. And remember that input for us are represented by x values. So remove any x values or inputs that we can't plug into the expression given for the function, so f of x. And of course, in this case, f of x is equal to the square root of x. So we already saw, when we saw this function before, that you cannot plug in any negative number into the square root function. And then the reason why, we went over it, let me just say it very quickly. You cannot square a number and get a negative number. Right? And that's basically the idea as to why you cannot plug in negative numbers into the square root function. Right? So if you want to review that, you can go back to the previous videos where we talked about the square root function a little bit more in detail. That was the example where we were actually graphing the function. So what does that tell us? Right? Since we can't put any negative x values into f of x, what are we going to do? We're going to remove all of those inputs from the domain, from the set of real numbers. Okay? So how can you write x values that are negative? That's the same as saying x less than 0, or using an equation. So remove all x less than 0 from the real numbers. And then anything that's left over is the domain. Right? So what is left over? Right, what's the domain of f? And remember that domain, we denote it by capital D and then parentheses f. This is the set of all x. And now here, you can write this two ways. You can either write element of the reals, or you can just write the set of all x such that. So you don't have to write element of the reals. Why? Because again, since I didn't say anything about the inputs and output sets, it's given in the context that all of the x values are real numbers. Right? So me writing x element of the reals is kind of redundant. Right? So you can write it like this, or you can just write the set of all x such that. Okay? And what x values are we keeping? Well, we're keeping the ones that are greater than or equal to 0. And we're removing the ones that are less than 0. Right? So what's the domain? The set of all x in the reals such that x is greater than or equal to 0. And that's how the more algorithmic approach that we're going to be taking to finding domain of functions. Now, this is a nice approach because I'm going to show you in the next video that there's really only two things you're going to have to worry about now in terms of expressions that you cannot plug in x values in. And other than that, everything else works. So it's going to be very easy.